Hello, hello, hello. So, today we are talking about this question maximum amount of robbery. Sorry, the maximum amount of uh, money that a robot can earn, right? So, the question is very straightforward that one grid is given of size m cross n. Let me zoom it. And the robot start from the top left corner, right? So, let us create one matrix for better understanding. Okay. So, I'll take the first example 0 1 minus 1, 1 minus 2, and then 3. And then we have 2 minus 3 and 4, right? Okay, more spacing. Hmm, okay, yeah. So this is one m cross n grid where the value of m is 3 and n is also 3, right? Now it says that we start from the top left corner. That means we will start from here. Okay, so we'll start from here and we can go in only two direction, either we can go towards the right or we can go towards the bottom down, right? Now, okay, so first condition we are aware that we can go either if uh, if you are standing here or any position, right? Here we can go towards the right or we can go towards down, right? And each at each position, so this is the value of coin, right? So each position we can gain some coins. You can see if coin's value is greater than 0 or equal to 0, let's say here the from here we go towards down. Okay, so here the value of coin is 1, which is greater than or equal to 0, right? Which is greater than 0, so we'll pick this value. Okay, now what if we go towards the right after this? It is minus 1, it is less than 0. In this condition the robot here it says that a robber will steal the value from coin. Okay, so it will steal the absolute value from coin. Okay, so what does that mean? That means the it will be removed. Basically, it will be removed from the whatever coin we had. Okay, so if the robot has one coin, so the robber will remove or it will rob one coin from the robot. Okay, so now the robot is left with 0 coins. Now what we go towards the down, so it will have minus 3. Okay, that means it will take 3 more coins from the robot, but robot is now left with 0 coin. So how the robber will take 3 more coins, right? So here we'll see that the robot's total coin can be negative, right? That means we'll assume that it will take 3 more coins from the robot, and robot will have left with minus 3 coins. Okay, so that is an assumption that we are talking now. One more thing that we have, that robot has a special ability to neutralize robbers. That means it will kill the robbers, but it has only 2 times that it can kill the robber. That means 2 times weak robbers will come in its path, and 2 times only it can kill those weak robbers. After that, strong robbers will come, and the robot cannot fight with the strong robbers, right? So at max we can use this ability 2 times only. After that, cannot use this ability. After that, what will happen? The robbers will steal from the robot and will minus the absolute value from the whatever coins the robot is having. Okay. Now return the maximum profit. Okay. So we have to return the maximum profit, right? So what you can think that this is a grid problem, right? But first thing, if we start, the first intuition that most of you and also which I got was we will traverse it. Okay, traversing is correct, but how will we traverse? Will we use a graph technique? Okay, so if you use a graph technique, how will you track your old values? Now here comes, to track the values, what do you use? We'll use an array or we'll use a dynamic array, right? Which we usually say a DP array, right? So okay, so what we'll do, we'll create one DP array, right? We'll create a DP array, and what will be the dimension of this DP array, right? So first we know that we need to traverse either I or j, right? So DP I, DP I and j. So what I and j will tell? DP and I and j will tell the best possible positive answer, the maximum coins collected, right? The maximum coin collected till index I and j. But there's one more thing, that we have neutralization. So let's say we have k neutralizations. So here it has already been told that we have two neutralization power. Okay, so what we'll say, k, I'll write it also, max coins collected till index I j using k neutralization power, which is equal to 0 to 2. Okay, now we have m value n value and dpi j and k, right? And we will start from 1. Okay, so what will be the actual value? How will we initialize dp n plus 1, m plus 1, and it will be 2 plus 1, or you can directly write 3. Now we will initialize the DP array as we usually do, right? So for this one I'll not write. For we will have three for loops, right? Three nested for loop, and for each okay, I'll write it only for I equal to 0 to n, m, for j equal to 0 to n, for k equal to 0 to 3. Okay, what will say, dpi j k will be equal to, we will not initialize with -1, because we know that here we can have minus values also. So what we'll do, we'll have int dot min val. Okay, it's just a pseudo code, so don't expect a correct code syntax. Okay, now, okay, now we initialized. So this is the thing that we have done. Now we'll start from our base cell, which is 0 comma 0, right? So at base we'll now initialize our dp array. Okay, for 0 comma 0. So dp initially what will say that, okay, we are taking the first value, considering that the first value is having a positive number. That means the robot will take the value, right? So dp 0 comma 0 comma 0, again, why 0? That means we are not using our neutralization power. Okay, so in this case we'll just say it's the coins value, coins I comma j is the value. Okay, now what if we need to neutralize? That means at 0 comma 0 there is some negative value. So what we'll say, dp not like this, coins 0, coins one more, coin 0 comma 0 is less than 0. If it is, mhm, if it is less than 0, that means we have to neutralize, right? So what we'll say, dp 0 comma 0. Now we will use the first neutralization power, 1 is equal to, what we'll say, we will skip this value, right? Neutralize means that we will not take this value. So we will not take this coins value. Okay, so we have one choice to take to skip this value. So we'll just keep it as 0. Okay, I hope this is clear. Now, in the next part what next part means. Yeah. Now in the next part, what we know that okay for okay TP00. Okay, so now this we have done. Now we'll start iterating for the next values. For I equal to 0 to m, let's copy 0 to n, and for k equal to 0 to 3. Okay, if now here one condition is there, that if I and j is 0, that means we have I and j, right? Sorry, this one is j now. If I and j is coming 0, okay, that means we are again calculating this base condition, right? So base condition we have already calculated, so what we'll do, we'll just skip this value. If I equal to 0 and j is equals to 0, equals double equals, so what we'll do, just skip it, continue. Now we'll have one best or let's say answer we can keep, right? Let's for now let's keep it as best value, right? So best, it's an integer dot main val. Okay, I will start from the top now. So for I greater than 0, if I is greater than 0, hmm, best is equals to math dot max, not writing the correct thing, just uh, uh, it's just a pseudocode, right? So if I is greater than 0, hmm, that means it's not we are going from top to bottom, right? Let me write it here only. Top, top to bottom. How we'll see that I is how do I understand that it's top to bottom? See, I is for all the columns 0 1 2 this way, right? And j is this way. Okay, so if I is 0, so it's obviously it's going towards the right. If I is greater than 0, that means I is not here. Okay, I has gone down, that means we are going towards the down position, right? Clear? This is very clear. I'm not going to explain this. Okay, so in this case what we'll do, we'll have our best value, that is best will, and dp I minus 1 will go to the previous value, that means towards the top. We have gone down, now we'll go towards the top and check I minus 1 j and k. Okay, whatever the value of k that we are having, right? Okay, for ij, this k, correct. Now so for top we are done. Hmm? Oops, it's not for, it's if. Now what we'll do, left to right, left to right, that means I will be 0, or let's say I whatever the value of I is there, j will be greater than 0, that is for sure, because we know that we can go down also, but from down also we may change our path towards the right. So I may be 1 or 2, but j will not be 0, j will be greater than 0, right? So what we'll do, we'll have the same condition if j is greater than 0, and again we have to take the max value for the best. So best is equals to max. Don't confuse that max is a separate function. Max is this math dot max, right? I'm writing math dot max only so that no confusion is there. Math dot max. best. And now where do we want to go? We are going from left to right. So at the right position we are already there. So we'll take the previous left value, right? Here what we were doing, we were checking the previous top value. So here we'll check the previous left value. dp I whatever is there will not will will not change the value of I. We just need to change j minus 1 and k. Okay. Now what do we need to see? That if the value of best is not minimum, okay, that means if best is not equals to int dot min val, then okay, when I value sorry the best value is not not minimum value. Okay, so here if you see best we initialize with minimum value, right? Now we need to check that. Okay, now after all this computation, right, after all this computation, uh, it's clear that if all these values are like some values are there, okay, so we'll have some gains. Okay, the coins will be gained, right? So after all these, uh, what what is the like if best is not equal to min, that means best, there is some value assigned with best that is like greater than this value. Okay, so we are not having the math dot min value, right? So in that case what do we need to do? We'll take the best and we'll add the current value, right? After doing these two calculations, after doing these two calculations, we need to also take the current position, right? We need to take the coins, right? What here it's take said that robot gains as many coins, right? Robot gains. Okay, so dpi jk equals to best plus coins of I and j, right? So it will gain this value. Now this is for taking. Okay, this is for taking. That means no neutralization and no okay, no neutralization. Okay, now here what we are doing, whatever be the value, be it positive or negative, we will take this in the coins. Whatever is the value, if it is negative also we are taking it, right? Why we are taking it? Because right now we are not doing any neutralization. Okay, we it's all just taking. Okay, so if if it is minus 1 it will decrease the value, right? So it will have this thing, robot will encounter a robber, right? Now we have to neutralize also, right? So first we are doing everything without neutralization. Now what we'll do, now we will neutralize things. Okay, how do we do that now? So what we'll do neutralization. Now what we'll do, if coins of I and j, when do we neutralize? Once this is negative, right? It's less than 0 and we are having some positive value for the neutralization power. That means neutralization, we have only two neutralization power, 1 and 2, right? Two times we can do neutralization. If it is less than that, then we cannot do neutralization. So we have to check if k is greater than 0, then only we can do neutralization. So means best two we can say again int dot main val. Okay, now if I is greater than 0, same thing, if I is greater than 0, so best 2 is equals to what will do, max max best, we were using their best, so here what we'll do, best 2 and dp. Now dp of I minus 1, that means the previous value j, and now here what we'll do k minus 1. Okay, correct. And now this was for top to bottom, going down, going right. J is greater than 0, greater than 0. Best 2 is equals to math dot max best 2 dp I as it is j minus 1, the previous value, and again do k minus 1. Okay, now, correct. Yeah, I think it's correct. Now now what we are doing, now we are checking again, this base 2 is not equals to int dot min value. Then what do we do, dpi j k, dpi j k is equals to math. Okay, so here what we were doing here, the best plus the current thing that we were taking, right? But how we here can we do this best plus coins? Hmm? No, because see, we are, once we are skipping it, right, skipping the right or the down value, right? So here what do we need to do, we'll have the current value and the previous value. The previous value is the best two only. Okay, so we can do this also, like best previous value, math.max. So here what we were doing, it was also a previous value. So best plus the current value we were adding, right? So here what we'll do, best previous and dpi j and k. Now here, if you see, in the first time we were adding it because it has nothing to do with neutralization. So anyhow, if it is positive, if this value is positive or negative, we'll just add it. Okay, and but here what do we know, that we have to take the best value using neutralization, right? So actually, if you see, so we are taking two answers. We are having one best value and we are having one best previous value, right? We are taking two answers. Okay, and here in dp of I j k, we are putting this value. Okay, so what will happen here also, actually it will come the best value, right, from here. Okay, now, okay, so now we have done this thing. Okay, at last we need to return our answer. So after all the for loops, for 1 2 3 1 2 3, return math dot max dp and m minus 1 n minus 1 and 0, or dot max dp m minus 1 n minus 1 of 1 dp m minus 1. I hope this is clear. N minus 1 and 2, right? So first thing, dp, first we are taking with zero neutralizations. Okay, So there is possibility that all the values are positive. All the values are positive. So we can take, like we don't need to do any neutralization, right? So we'll just take the best value without any neutralization thing. Second thing, that there is, we encounter only one robber. So we do one neutralization and then we take the best positive possible value. Third time, third condition that we can have, that we have to do two neutralizations, and after that whatever is the best possible value, we'll just take it, right? So this is the pseudocode. Okay, now I will simply write the code here. So let's take this, and m equals to coins dot length, and n equals to coins of 0 dot length, int deep equals to new int m comma n n 3. Okay, now we have for I equals to 0, I less than n, I plus plus, for int j equals to 0, j less than n, j plus plus, and for int k equals to 0, k less than 3, k plus plus, what we'll do, dp of I j k is equals to integer dot main value, value. Okay, okay, now take the best case, sorry, base case, dp 0 comma 0 comma 0 0 equals to coins 0 0. Okay, so this is the best case. That means uh, coin 0 0 is positive. Considering base value as positive. Now if negative, use one neutralization. So here what we'll see, that if it is negative, we'll use our neutralization power. Okay. Hmm. Coins 0 0 is less than 0, then what we'll do, dp 0 comma 0 comma 1, it will be consumed, is equal to 0. Okay, so we have consumed the first neutralization power and set it as 0. So we are actually skipping it. Skip base. Okay, now for int I equals to 0, I less than n, I plus plus. If you want to do it by yourself, try doing it yourself, because I have already given the pseudocode. It's similar to the pseudocode itself. I equal to 0, j equal to 0, j less than m, and j plus plus, and then we have k for, okay, int k equals to 0, k less than 3, k plus plus. If I, now if you see, what was the condition we have to skip? Yeah, this one. If I j is 0, so we'll just skip this, condition. If I equal to 0 equals to j equals to 0, just skip it. Else what we'll do, we'll take one best value, right? Int best equals to integer dot min value. Okay, now we are going down the grid. If I is greater than 0, then what will the value of our best equals to math dot max best dp I minus 1 j and then k. Correct? K, we are not using k. Okay, so we are not doing any k minus 1 because this time we are not doing any neutralization. Okay, now going right in the grid. If j is greater than 0, best equals to math dot max best dp I j minus 1 previous j value and the k. Okay, now what was the condition? We have to check if it is not equal to integer dot min value. Integer dot min value dp I j k equals to best plus the coins current value, coins I j uh, sorry k. Okay, so this thing is done. Now what we are doing, using neutralization, we are taking, that means no neutralization. Okay, now we need to do neutralization. Okay, so I'll copy this better. Okay, do we need to check do neutralization? Yes. So when we are doing neutralization, first we have to check this one, right? That if coins value is the current coins value is less than 0, means that if it is negative or not, and we have neutralization power left, right? Okay, coins ij is greater than 0. Okay, this is correct. Best figure equals to, okay, this one, integer dot min value. I'm not explaining too much here because explanation I have already done. So better to go little back and watch. Okay, so if this is correct, previous this is also correct. Integer dot min value, math dot max. Okay, correct. And this is close, and this is for, oops. Okay, these three parentheses are closed. Okay, we are doing dp equals to math. Correct. At last we'll return it. Mm, Now return math dot max. What we are doing for returning here? You see, dp, three things we are checking, right? First without neutralization, then first neutralization, and then with all neutralizations. Okay, there is some compilation error. Required, array required. but found int. Okay, plus plus. Okay, if best, no neutralization. Correct. We are doing this right only. First if, second if, third if. dp of ijk. Coins. Oh, coins is not having j, right? Sorry, k. Coins is only a 2D array. Are we doing the same here? Correct. Best to, cannot find symbol best to. Okay, best figures we are using. Yeah. Okay. So yeah, so this is the solution. I hope this was very clear. So first time we are doing without neutralization, second time we are doing neutralization, and how we are doing neutralization is very simple. Is very simple. Okay, if you have any question, comment down. I'll try to answer. Thank you. Thanks for watching.